Good afternoon, everyone. You are welcome to my YouTube channel. If you have watched the video before this, you see where I did some analysis, and I promised to come up with a video where we'll see how it is done. I'm missing the salt here. It escaped my mind to show you before I miss it. It's somehow very light blue crystalline solid. So I'm mixing it with water. Shake. When you observe, you see the coloration. If you observe with what I said, sample with water. All right. Sample with water shows what? Blue solution. It dissolves to form the blue solution, and that confirms the presence of what? Copper 2 salt. So under your inference, you write copper 2 salt present. You can see copper 2 salt present. And I remember telling you that you could be asked to do litmus test or not. If not, just for you to have an added mark, you can just do litmus test. All right. Let me get my litmus. Okay, this is my litmus paper. All right. So we want to confirm that it is neutral to litmus. All right. Both blue and red. Both blue and red. Confirm that is okay. All right. So let's test for the blue. All right. See up top. Bring it up. Can you see? Can see? Can see? No change. To blue litmus, no change. On red. No change. That means solution, under inference you put solution is neutral to litmus. Neutral to litmus. Alright? So what you do, they will tell you to divide into 3 or 4 portions. Alright? So just put small of that. Small. Okay? You'll be told to whatever portion it is, 3 or 4 or more. Alright? You divide into the portions. Okay? Alright. Now, depending on how it comes, alright, for me now here, I'm going to do just as the booklet I posted before now. The first I'm going to have is with sodium hydroxide in dropwise. Sodium hydroxide. Where's my sodium hydroxide? Okay, this is my sodium hydroxide in dropwise, then in SS. In dropwise, then in SS. Look at it. Alright. Observe the color. Observe, then in dropwise. Can you see the precipitate? Precipitate formed. Blue precipitate forms. That's in drop. Then in SS. Precipitate is not dissolved. So what you will write under your observation is pale blue precipitate forms, comma, insoluble in SS. Insoluble, that means it didn't dissolve. You can see the precipitate. Can you see? You can see the precipitate. Insoluble in SS. So that is your first portion. So to the second portion, should it be second or third, however it comes, but for me here, my second portion is to add aqueous ammonia. Aqueous ammonia. Aqueous ammonia in drops, then in SS. Aqueous ammonia in drops, then in SS. Can you see? Aqueous ammonia in drops. In drops. In drops. Alright? So that is a pale blue precipitate. You can see the precipitate. Pale blue precipitate forms. Then let's see in SS. The pale blue precipitate. The precipitate are still there. I was expecting a deep blue precipitate that do not dissolve. Alright. Maybe there's something wrong with this my ammonia. Alright, I will still come and check on that later. Maybe when I check that, I will give you another video of such, because I'm expecting to see a deep blue dissolved precipitate, but I'm still seeing pale blue and the precipitate are still here. Alright, so let's mark that one. We'll come back to that in another video, alright, to save time. Okay, alright, so its difference should be pale blue precipitate forms, dissolves in excess ammonia to give a deep blue solution. Alright. Okay, the next one now is for me, the third portion is to add dilute HCl. Okay, before dilute HCl, we'll add barium chloride, aqueous barium chloride. Okay, so I'm expecting to see white precipitate. If you have studied the other video I gave you, so go and check the other video. Let's see what will happen. Barium chloride. Expect to see a white precipitate. Oh wow, that's correct. So this is a white precipitate. Well, I don't know if the video is showing you something else, but I'm seeing white here. Right. This is white precipitate. You can see white here. White. Alright. Then the next one, white precipitate. Then add dilute HCl. Dilute HCl. Dilute HCl. Wow. The white precipitate is here. The other one that forms with ammonia, we say it confirms the presence of iron 2 plus, copper 2 plus, copper 2 plus ions confirmed. But this one that is white precipitate, that first white precipitate with barium chloride indicates so many ions such as SO4 2 minus, SO3 2 minus, or CO3 2 minus. But when I add dilute HCl and the white precipitate remains insoluble in the presence of dilute HCl, that confirms the presence of what? SO4 2 minus. So under your inference, you write SO4 2 minus present. Listen to what you are going to write. Under the inference, under the barium chloride, you write SO4 2 minus, SO3 2 minus, CO3 2 minus present. Then plus HCl, you now write under it SO4 2 minus present. Do you get that? Okay, that's the possible portions you'll be dividing your whatever. But we put we have Fehling solutions. There are two Fehling solutions, solutions A and B. All right, I would like to go with B based on experience, and we expected to add this Fehling solution and heat, and when you heat, you expect to see a what? A brick red. So I will pause the video now, go and do that. Then okay, when I do that, I'll maybe I can bring the heat closer so that I can see how it is done, so it will look real to us. All right, okay, all right, okay. This is the Fehling solution. All right, so we'll pour Fehling solution, then we'll go and heat. Okay, this is the Fehling solution poured. All right, let me get the heat. All right, my lab here is not so the heat is an improvisation. All right, so I'm going to improvise. So you can see. All right, okay, so I want to heat that up. Alright, this is my test tube holder. So this is my lighter to make the fire. Alright, the fire is up. Okay, so let's heat up. We're expected to have a deep what is it called? Heat strongly. If you observe, you see that the color is changing. We expected to have a brick red. If you look at it, you can see it's changing. Alright, so let's continue heating. You can see the color is changing, right? Alright. We're expected to have a brick red. So the color has, all the blue is off. So that the copper ion is turning to copper oxide. That's when you are testing for your sugar. Alright. So then the presence of the brick red confirms the presence of what? The sugar, reducing sugar. So can you see? Can you see? That's the brick red forming. You have to heat strongly. You can see. You can see the brick red. Alright? Can you see it? Alright. Okay, I'm going to turn off the gas now. You have confirmed the brick red. Alright. Good. That's the put down the gas. Alright, so what do you write there under the test? That's a solution plus Fehling solution, then heat. Alright. Under observation, brick red precipitate forms, and under the inference, that's reducing sugar present, or you can say, I would advise to write reducing sugar in brackets, glucose, close the bracket, present. That's this test. So that is it. That's all we have. I'm sure that it will not be more than this. It will not go beyond this. Alright, it will not go beyond this. I wish you all the best. Study it very well. If you have not subscribed, please subscribe. Another video will be coming very soon. That will be where I will propose a suggested questions for the metric analysis, so that you can be very, very appraised. We are here to make you pass, and to pass very well. Share the link to your friends. If you have not subscribed, you are meeting up for the first time, this is the Dawn's Consult. Subscribe, and we are here to help you. Thank you. See you in the next video.